pops up is a function of how the spread happens. Sometimes the spreads can be completely different, but still bring up the same waveform, which basically means your prediction is mathematically correct, but probability-wise, it's completely wrong. So just going through the motions of solving a correlative function isn't going to necessarily bring you any closer to finding any real correlation. Naive Bayesian algorithms are usually used for correlation in data sets because they're very fast, but they are not usually very correct. They're good for classifying documents, which is largely what you're doing when you're doing data analysis on a network. Naive Bayes make certain assumptions. Bayesian algorithms in general make assumptions. There are schools of statistics that are not fans of assumptions. If you go into your PhD thesis with a naive Bayesian algorithm in there, odds are you're going to get tore up. Because if you're on a PhD level, they want your numbers to be exact and accurate. Bayesian algorithms don't produce exact and accurate results. Just like when Fermi was figuring out the blast yield of the bomb, his accuracy was based off certain assumptions. He was making guesstimates, lots of them. You don't functionally need to always be correct. You don't functionally need this, and that's why Bayesian algorithms are great. When we were trying to discover a way to figure out how to stop spam from showing up in our inbox, some guy thought, hey, we don't need to be right all the time. We just need to be right 99% of the time. Bayesian algorithms work for that. But most of you know all this. Weka. Weka's, well, actually, I think I skipped a couple here. Yeah, okay, so here's a picture of not Thomas Bayes. He was a religious nut and accomplished mathematician. He gave us a Bayesian theorem from which many other algorithms are derived, including naive Bayes. That's the Bayesian theorem. It's pretty straightforward. It's not super hard, but it is a shit ton of iterative math. Weka. Weka's really cool. Weka is like many other very expensive tools, except it happens to be free. Yes, so the good side is it's open source. It means you're not going to pay a lot for it. It can be modified. There's a lot of plugins for it. It works with a lot of different data acquisition tools. The negative sides are it's slow, and it stores everything in main memory, which means if you've got a very large data set, it's going to crash, and it's going to crash hard. It does, however, have the option to work off a JDBC, and it can work off of a SQL server, which is pretty straightforward and useful. But the reason we use Weka is not because it is your end-all. The idea is to use Weka to figure out how you're going to model your data. You throw a small part of your data set in, figure out where the correlations lie, or how you want to go through it and look for correlations. Then you do it in another set of code. Probably see if it's a large data set. If not, you can probably model it in Weka. It works. Okay. This is going to get really dicey now. If I could see my mouse. Okay. Wow. I should have brought a spare machine. Okay. You know what? I don't think I'm going to bore you with this. Weka is really cool, but I'm only going to show you a small part of it because I can't see the screen. Then I'm going to have a discussion with something else. Open. Go up. No, that's not the right directory. Is that the up? Yeah, I have no idea where I am. Yeah. Okay. So that's not the right directory. Hope is there. All right. It should be in demo 1.
Is this just because it's Java?
Yes. Okay, what is it looking for here? Okay. That's not going to help us. Man. Yeah, I can't see this. Okay, so Weka, I'm just going to explain it to you. Weka allows you to do visualizations. If you open up an ARFF file, which is basically kind of like really weak XML, you basically dump it in, you define your data types like a very simple database. So say you're doing a Perl parse off the schedule of talks, you can grab the title, the descriptive analysis, and the author. You've got 3 different sets of data there. You're going to describe basically other stuff if you want it is location, the size of the room. We know that Ingratiates is the smallest room, which means obviously no one thinks highly of me, which is probably correct since my laptop doesn't work and I'm looking like a fool. But you throw all this data into Weka, you define the data types, and then you can run certain sorts and searches, and you can run linear regression by itself in about 15 different algorithms. You can run correlation off of about 15 other different algorithms, and it'll give you a correlative coefficient. And if the correlative coefficient is near 0, it means that there's probably no correlation here. So functionally, if you're looking for data, you extrapolate a shit ton of data on your target. Great targets of past exploration have consisted of, and this asshole over here forgot to give it to me, was he's actually sitting on psychological profiles of hackers in the New York City area over the years. That would make a great data set. Another great data set I've used is pastebins. Pastebins contain code snippets and configuration files from the pastebins on Freenode. Does anyone not know what a pastebin is? Okay, so if you're on IRC and you're looking for help, someone gives you a website to paste your configuration or your source code into, and then you give them the link and they can see it. A lot of these are configured with either linear serial counts or a recent post page. So you could develop a spider to sit on there and pick that shit up, and you can play with it. Do simple stuff like searching and sorting keywords like password or MySQL Connect, or just off of extrapolation you can find a shit ton of really cool stuff. But the really cool stuff is when you start looking for failures that exist in code. You can look for buffer overflows in printf. You can look for system calls with variables in them. And then you can start figuring out which developers, because they usually sign their names, are the bad ones. You can also see across the board what mistakes are likely to happen with certain types of code. This is useful data for a person who's a systems administrator and wants to make sure that his developers are not screwing up constantly, but doesn't want to get involved in looking at their code. You can just throw out at a meeting, hey, listen, you're a PHP developer, we just want to make sure that you're not using a shit ton of persistent connections constantly. Or, you know, you need to make sure that anything with a MySQL connected it is not set up so that anyone can read it. You know, simple stuff like that. Schedule of talks, getting back to that, is when you extrapolate data based off of people and keywords. You can do lexical analysis thanks to an application by Princeton University called WordNet. WordNet allows you to look at a sentence, break apart the words, and pull the noun values out of this sentence. Using that, you can actually basically set up keywords. I'm looking for usage of the word hack, so it'll give you hack, hacking, all the other stuff you need. I'm looking for usage of data mining. I'm looking for usage of culture jamming. I'm looking for usage of whatever's happening, and you could basically look at the, I actually wish I could show you, but I got the Perl code to do this. You can extrapolate, pull this data out, look at those numbers, and dump them into the Weka. So you can look at the numbers in such a way where you're saying, okay, we're all in this room, we're all going to talk, certain talks are in bigger rooms, certain talks are obvious of greater value. So what this year is of the greatest importance to all of us? It's pretty easy to figure that out just based off the weight of numbers. But you might also look for correlations. What people throughout the years are seeing this and going, hey, this is great. And added to that, with the attendee metadata project, you can actually see who's going in and out of rooms based off of the location tracking on here. So we can know whether or not a lot of people come to a talk and leave because it sucks, like my talk, I'm sorry. Moving on from there, Extrapolating data, so what it basically comes down to is you first want to define your data set. You're looking, you're hunting, you're saying, I want to know more about a specific area. Let's say I work as a system administrator, so what I'm concerned about is whether or not our sensitive data sets are available to someone or predictable. So I want to define, here's my sensitive data, here's the stuff that's connected to it. I pull all of that into a room based off keywords, and I throw that into Weka and start analyzing. I look for correlations between the full set of code base and path data for all of our web apps. Do that, and we'll end up with possible correlations on usernames, possible correlations in usage of functions by specific developers, things of that nature, and you'll be able to, in theory, shut down uses of predictable data where, say, a developer likes to use this God username, God. So one of your developers likes to use God a lot, hides it in his code. You don't want that popping up a lot. So developer X correlates with rapid recurring God in username. You see that pop up because instead of doing the searching of all the code yourself, you're running it against Weka or an application that's otherwise doing linear regression, and that you're extrapolating it, doing linear regression, then doing correlative analysis. And if the correlative coefficient is above 0 by a pretty decent margin, say closer to 2 to 90, you might want to be sitting there going, hey, this might be something I want to take a look at. You look at the graph without even looking at the data, just look at the graph and see if the graphs match up. If they do, then you look at the data and say, could there be a correlation here? Could there be a causality that makes sense? If not, then obviously you didn't find anything. There's a lot of data analysis that goes bad. You won't find anything, as we didn't get to see with the mailing list. Mailing list, in theory, you would think that high traffic means that the project's doing well. Usually that's not the case. A lot of projects have a lot of high traffic and don't actually do jack shit. But some do. The other thing that you would think is that you can push things like looking at, how do I explain this? Okay, so you have a mailing list. Sometimes you won't see certain things immediately, and sometimes you'll be able to use things that you didn't otherwise think you could. For instance, when you're looking at a mailing list archive, you'll pull up, a lot of them will have gzip digests, some won't. Can you pull the values of gzip digests and use them against the values of the non-gzipped? Usually yes, because you can actually figure out predictably what the difference in size will be. We don't care about exact numbers, so you can actually generate, using predictability, naive Bayes, what the actual value difference should be on a scale ranging from starting at 5K on up to like 96K, on up to 70K digests. I am dying up here. I'm going to take a question or two, see if anyone's lost. What? Say the question again.
How much does representation screw up your ability to go and find the correlation?
Define representation.
Well, so I mean, you said you can look for like these uses.
Yeah.
It seems like.
Oh. In some cases, it screws it up thoroughly. In some cases, it doesn't. It really depends on this is what correlative analysis is about. You need to look at the correlation and extrapolate all other data and isolate only the ones that matter. That doesn't mean all but two. That means only the ones that matter. Sometimes the underlying stuff that does matter is extrapolated as well. For instance, there was a weapons testing program done by the military where they set up a camera that was supposed to look at an image and define whether or not it was an enemy or not an enemy. And it was working in the lab every day. Works fine. They assume, you know, the picture's an enemy, not an enemy. It's pretty straightforward. But they bring it outside and all of a sudden it's not working. Why is that? Pictures taken of it, enemy day were nice day, allied day, not a nice day. It started picking up the weather patterns instead of the enemy, not enemy. So there's a correlation there that isn't actually correct.